The air is still cold. What if tomorrow morning you woke up and saw two suns in the sky, two shadows behind you, twice the heat, twice the light? On the horizon, a familiar arc of intense orange begins to push back the darkness of night. It is the sunrise, a celestial event our planet has witnessed for over 4 billion years. But this morning is different. As the first sun clears the edge of the world, bathing the landscape in its warm, familiar glow, a second point of light appears beside it. It is smaller, more intense, a brilliant white diamond rising in tandem with its golden companion. Two suns breach the horizon. The desert floor is instantly painted in a complex wash of overlapping light and color. The man's shadow, once a single, lonely figure stretching across the sand, is now accompanied by a second, fainter silhouette cast at a slightly different angle, and a world that will never be the same again. The sky is no longer a simple gradient of blue. It is a tapestry woven with two sources of brilliance. The warmth on his skin is immediate and more intense than any he has ever known. The silence of the dawn is broken not by sound, but by the sheer, overwhelming presence of a sky that should not be. This is not our Earth, not anymore. The initial shock gives way to a disquieting awe. The mind struggles to reconcile the impossible sight with the familiar setting. Every instinct, every biological rhythm hardwired into our species by millennia of single sunrises, screams that something is fundamentally wrong. The world feels unbalanced, as if the very laws that govern our existence have been rewritten overnight. The air begins to shimmer with a heat that feels premature, a harbinger of a day that will be unlike any other in human history. The question hangs unspoken in the superheated air, a thought that would ripple across the entire globe. What happens now? This cinematic vision, once the domain of science fiction, forces us to confront a profound astronomical reality. We are tethered to a single, stable star. Our lives, our climate, our very biology are all sculpted by its solitary, predictable journey across our sky. But what if that were not the case? What if starting tomorrow, a second sun ignited in our celestial neighborhood? Would our world, so finely tuned to the rhythms of one star, be able to withstand the gravitational pull and the radiant energy of two? The survival of everything we know would depend on the answer. Yeah. Our perception of a single sun in a serene sky is a profoundly local experience. When we turn our telescopes to the cosmos, we discover a striking truth. Loneliness is the exception, not the rule. A significant portion of the stars in our Milky Way galaxy are not solitary travelers like our sun. Instead, they are bound together by gravity in pairs, or even larger groups. These are known as binary star systems. Current estimates suggest that over half of all sun-like stars in the galaxy are part of a binary pair. From a galactic perspective, our single star system is an outlier, a quieter, perhaps more stable neighborhood. These stellar pairs engage in a perpetual gravitational dance. Some binary systems feature two stars orbiting a common center of mass in wide, leisurely loops that take thousands of years. In these cases, the stars are so far apart, they barely influence one another. Other systems are much more intimate, with stars orbiting so closely they can exchange material, their atmospheres bleeding into one another in a dramatic embrace. The variety is immense. Pairs of near-identical stars, systems where a massive giant is orbited by a tiny, dense dwarf star. The universe has a fondness for creating dynamic duos. The birth of our solar system some 4.6 billion years ago was a chaotic and messy affair. It began with a gigantic, spinning cloud of interstellar gas and dust, the solar nebula. A glowing disk of gas and dust swirling around two young protostars. At its heart, gravity pulled material together into a dense, hot ball that would eventually ignite to become our sun. The rest of the spinning disk gradually clumped together to form the planets, moons, asteroids, and comets we know today. This standard model of solar system formation works well, but some lingering mysteries have led scientists to propose a fascinating addition to the story: a stellar twin for our Sun. This theory, often referred to as the Nemesis hypothesis, suggests that our Sun was born as part of a binary system. Its companion, a faint and distant star, would have coexisted with the Sun in the early days of the solar system. Proponents point to certain anomalies in the outer solar system, such as the strangely perturbed orbits of objects in the distant Oort cloud, a vast spherical shell of icy bodies surrounding our system. The gravitational influence of a long-lost sibling star, they argue, could explain these and other cosmic oddities. According to this hypothesis, the Sun's twin would not have been a close companion. It likely orbited our Sun at a tremendous distance, perhaps thousands of times farther than Earth's orbit. For millions of years, this dim star, Nemesis, would have been a quiet member of our cosmic family. However, binary systems are not always stable forever. The gravitational pull of other passing stars in our galactic neighborhood could have eventually disrupted the delicate balance. Over time, these external tugs could have been enough to strip Nemesis away, sending it off to wander the galaxy as a solitary, rogue star. Gravity is the master architect of the cosmos, the silent force that holds galaxies together and keeps planets in their paths. In our solar system, the Sun's immense gravitational field dictates the orbits of all the planets with remarkable precision. The planets in turn exert tiny gravitational tugs on each other, but these are minor perturbations in an otherwise stable system. The introduction of a second sun would shatter this equilibrium. It would be like adding a second powerful conductor to an orchestra, each one demanding a different tempo. The result would be gravitational chaos. The fate of Earth would depend entirely on the mass and orbital path of this new star. If the second sun were to pass through our solar system on a transient path, its gravitational influence would act like a cosmic wrecking ball. Planetary orbits, including Earth's, could be stretched into highly elliptical shapes. A stable, nearly circular orbit is key to our planet's temperate climate. A new, elongated orbit would subject us to wild swings in temperature, scorching heat when close to a sun, deep freezes when far away. The delicate balance that allows for liquid water and life would be irrevocably broken. In a more extreme scenario, the gravitational pull from the new star could be strong enough to eject Earth from the solar system entirely. Our planet would be flung into the dark, frozen void of interstellar space, becoming a rogue world without a star to warm it. Any life on the surface would be extinguished almost instantly as temperatures plummeted to hundreds of degrees below zero. Alternatively, Earth could be pulled into a collision course with another planet, or worse, with one of the two suns. The end would be swift and fiery, a final catastrophic plunge into a stellar furnace. Even a seemingly stable configuration, where Earth orbits both stars, is fraught with peril. Such an orbit, known as a circumbinary orbit, would likely be far from a perfect circle. Earth would wobble and weave through a complex gravitational field, its path constantly being tweaked by the two shifting stars at the center. The length of a year would be in a constant state of flux. The tilt of our axis would be in a constant state of flux. The distance from our energy sources would be in a constant state of flux. Beyond the gravitational upheaval, the most immediate and obvious change would be in the light and heat reaching our planet. With two suns in the sky, the concept of night might cease to exist for large parts of the year. Imagine a world bathed in perpetual daylight. One sun sets only to have the other rise. Both hang in the sky simultaneously. This constant illumination would have a profound and devastating effect on the planet's energy balance. Our world is accustomed to a cooling off period, the night, which allows it to radiate excess heat back into space. Without it, temperatures would begin to climb relentlessly. The sheer amount of energy striking the Earth's surface would increase dramatically. Even if the second sun were smaller and dimmer than our own, its contribution would be significant. Global average temperatures would soar, triggering a cascade of climate catastrophes. The polar ice caps, which act as the planet's primary reflectors of solar energy, would begin to melt at an unprecedented rate. This would not be a slow, centuries-long process. It would be a rapid and unstoppable collapse. As the ice vanished, darker ocean water would absorb even more heat. Land beneath the ice would also absorb more heat. That creates a powerful feedback loop, accelerating the warming further. The world's oceans would bear the brunt of this thermal onslaught. As sea levels rose from the melting ice, coastal cities would be submerged. Low-lying regions across the globe would be submerged. But the rising waters would only be part of the problem. The surface layers of the oceans would heat up, driving massive desert expansion as evaporation rates skyrocket. Temperate zones that support our agriculture would become arid wastelands. Civilization itself would be unable to sustain much of human life. Earth would transform into a hothouse planet, more akin to Venus than the world we know. This unblinking glare would also alter the very composition of our atmosphere. The increased energy could trigger chemical reactions that break down water vapor in the upper atmosphere. That would allow hydrogen to escape into space over geological timescales. This is a slow but irreversible planetary desiccation, a gradual drying out of our world. The intense ultraviolet radiation from two suns would bombard the surface, posing a lethal threat to any life not adequately shielded. The sky would no longer be a protective blanket, but a source of relentless, life-extinguishing energy. The existing biosphere, finely tuned over billions of years to the rhythms of a single sun, would face an immediate and existential crisis. The diurnal and nocturnal cycles, hunting patterns of predators, pollination activities of insects would be thrown into chaos. Animals that rely on the cover of darkness avoid predation forage for food would find themselves exposed and vulnerable. The distinction between day and night, a biological metronome for life, would be erased, leading to a widespread collapse of ecosystems. Photosynthesis, the base of nearly all life, would be pushed to its limits. Plants need sunlight to live, but too much can be as deadly as too little. Intense, unceasing radiation from two suns would overwhelm plant photosynthesis, causing bleaching and death. Forests would wither, grasslands would turn to dust, phytoplankton would perish. Plant collapse would trigger a domino effect up the food chain, leading to mass starvation and unprecedented extinctions. Life is resilient. Evolution would work furiously to find solutions. Over vast timescales, new life forms might emerge. The climatic consequences of a two-sun system would extend far beyond simple heating. The complex interplay of light would create weather patterns of unimaginable violence. The complex interplay of gravity would create weather patterns of unimaginable unpredictability. The concept of seasons, as we know them, would likely vanish. Instead of a regular progression from summer to winter, Earth would experience erratic, extreme thermal swings depending on position relative to the two stars. Long periods of intense, planet-wide heat could occur. Sudden, dramatic cooling could follow as the planet moved through gravitational and thermal shadows. This extreme energy differential would spawn storms of monstrous proportions. Temperature gradients between the perpetually sunlit side and the cooler, twilight regions would drive winds of incredible speed. Those winds would create hyper-hurricanes dwarfing anything in Earth's history. These storms would rage across continents. They would also sweep across oceans. They could last for weeks or months at a time, carrying torrential rains, causing catastrophic flooding in some regions, leaving others in permanent drought. The planet's weather would become chaotic and violent, swinging wildly with little predictability. The geological stability of our planet would also be threatened. Varying gravitational pulls from two stars would exert immense, constantly changing tidal forces on Earth. That wouldn't just affect the oceans. Massive, unpredictable tides would reshape coastlines daily. The planet's crust would be stressed, increasing seismic activity. Earthquakes would become more frequent and powerful. Volcanic eruptions would also grow in frequency and intensity. The very rock beneath our feet would be stretched and compressed by the celestial tug of war. The atmosphere would be choked with ash and volcanic gases, altering climate further. In this turbulent world, the sky itself would be a source of dread and wonder. The supercharged atmosphere, full of aerosols, would produce spectacular optical phenomena. Sundogs, halos, other complex atmospheric effects. Auroras might become global, not just polar, as the planet's magnetic field is battered by the combined solar winds of two stars. It would be a sky of terrible beauty, a constant reminder of the planet's violent, unstable condition. Let us return to the ground to the human perspective in this transformed world. Imagine standing under a sky with two suns. The simple act of looking at your shadow would become strange and disorienting. You would cast not one, but two distinct shadows different in length and sharpness. One dark and crisp, one softer and ghostly. As the suns moved across the sky at different speeds, your shadows would dance and rotate. Day and night would be completely rewritten. Sunsets would be drawn out. One sun dips. Clouds glow red and orange. The other keeps the sky bright. True darkness might never come. Perpetual twilight, an eerie, half-lit world. Sleep disrupted and psychological strain. The romance of a starry night would be lost, bleached away by the unending glow. The quality of the light itself would be different. A yellow G-type sun and a smaller, redder M dwarf. The world would be bathed in mixed colors. Objects would shift color with the dominant sun. Warm golds and cool whites. Strange, rosy tones. Double shadows. Perpetual light. Shifting colors. Our art. Our architecture. Even our language. How would we build our homes with no true night? What myths and religions would arise to explain two gods in the sky? The wonder of witnessing two suns rise, tinged with instinctual dread. The light that gives life becomes a constant, menacing presence. While the sudden introduction of a second sun to our solar system would be catastrophic, this does not mean that life is impossible in binary star systems. The universe has proven to be more imaginative than we often expect. Astronomers have discovered real-world examples of planets that exist in stable orbits within two-star systems. The key is the orbital configuration. If a planet orbits very far away from a close pairing of two stars, treating them as a single gravitational point, it can maintain a stable circumbinary orbit. This is the scenario famously imagined on the fictional planet Tatooine. One of the most remarkable real-life discoveries is a planet named Kepler-16. This is a gas giant, about the size of Saturn, that orbits two stars that are themselves orbiting each other. From the surface of one of its moons, you would indeed see two suns in the sky. The discovery of Kepler-16 was a landmark moment, proving that planets can and do form and exist in stable orbits around binary stars. Since then, astronomers have found numerous other circumbinary planets, confirming that planetary systems around two suns are not just a theoretical possibility, but a common feature of our galaxy. For our Earth, a world sculpted by and for a single star, the arrival of a second sun would almost certainly spell doom. Yet, when we look to the stars, we see that the universe is not limited by our experience. Stable, beautiful worlds can exist in arrangements we once thought impossible. The existence of planets like Kepler-16 is a testament to nature's ingenuity. It reminds us that our cosmic solitude, the gentle fidelity of our one sun, is both a profound stroke of luck and just one of countless ways to build a solar system.